Hi, let's talk about service software for ultrasonic liquid level sensor Eurosens Dizzi. This utility is used to find the best installation place for sensor. Second utility is used to enter the license key and change sensor settings, type of liquid, sensor interface, calibration table, and other parameters. And we use third utility to update the sensor firmware. First, start of software for searching the installation place. Run Oscilloscope, connect USB RS485 adapter with sensor and choose correct COM port and sensor address on RS485 line. Default address is 1. There are 5 possible user profiles. Each profile contains user preferences for convenient operation, maximum and minimum signal level, and parameters how to draw a plot. Click Start button to poll sensor for data. Here we can see serial number, firmware version, and sensor settings. In this field, we can switch on parameters to monitor. Button N opens noise reduction settings. We'll talk about it later. That's how we find the best installation place. Connecting sensor. It is advised to set maximum amplification coefficient during this phase. Put acoustic gel on sensor surface. Trying to attach sensor to the tank bottom. Here we can see some peaks of signal. They are caused by reflections. The more reflections, the better. We can scale this axis to see more. Move sensor and try to receive as much reflections as possible. Important: reflections must be declining to the right side of the scale. The second criteria is installation parameter quality. We have 100% now. After the best installation place was found, we cover the sensor surface with glue and fix the sensor with metal ties. Then we will set up the sensor's noise protection. Set minimum amplification value to 1. Click N to enter Noise Reduction Editor and switch on Edit mode. Noise consists of constant part caused by sensor components and variable part which is caused by installation and tank properties. We will try to remove the constant noise part at first. Horizontal line with triangle sensitivity limit. Increase resolution to maximum. Noise should not intersect our sensitivity limit line. This line must be above noise. After this easy step, we move to the beginning of chart. increase resolution of time. And for every scale coefficient, we added our filtering curve. Left mouse button allows to move filtering curve at single point for each scale coefficient. With right button, we can move all points of curve. We can see that constant noise level intersects the filtering limit level, so we move shift point to the right. Another intersection here, shift point to the right. Repeat procedure for each amplification coefficient. After finish, we exit the edit mode. Stop sensor and write configuration to sensor. Then we go to configuration utility. Reading sensor data. We can see the serial number of sensor, firmware version with latest date of sensor update, and firmware update counter. Also, version of sensor configuration, its date, and sensor configuration counter. On the License tab, we can see that this sensor can be used to measure level up to 1000 millimeters. We can choose the type of liquid. If you can't find your liquid there, we can set up it by polynomial or table information about acoustic speed as function of temperature. Set the maximum level. Also, type of tank. Tank calibration table can be stored in sensor, so sensor output will be proportional to the liquid volume. We can use either polynomial or table calibration data. We can also set further signal calibration or scaling. For example, we want to know not level height, but distance between tank cover and liquid. In this case, we can recalculate it there. In the calculation example, we can see a preview of results. If sensor measures 100 mm level, we will receive 200 mm distance between tank cover and liquid level, and this value will be sensor output. Also, we can set up sensor output to show relative level of volume in percent. With maximum 300 mm level, measured 130 mm will give us 43%. If 1 mm resolution is not enough, you can set scale factor 10 to sensor results. So, with measured 100.5 mm level sensor, will provide 1005 value, which you can recalculate to values with decimal point at software site. And you can decrease the sensor resolution as well using scale coefficient 0.1 to its output. At this step, you can choose an interface of sensor, RS485 digital interface, frequency interface with different modulation type, frequency and pulse width modulation. Minimum frequency will correspond to minimum level. Maximum frequency corresponds to maximum level, which you can set up as well. Also, we can set if zero value is restricted or not. You can also use analog voltage output in range from 0 to 5 volts. We can set as well minimum and maximum values and corresponding output voltages. We can set up also fuel level sensor protocol details, baud rate, type of data to be sent, sensor addresses on RS485 bus. Also, sensor can provide data by Modbus protocol, and you can choose Modbus data format there. Sensor will provide zero value if can't see reflection signal. For example, when tank is tilted relatively to horizontal surface, it cannot be convenient when sensor installed on tank of vehicle. You can deny zero values as output. Sensor will send last actual data instead. Or you can set a period of time after which zero value output can be allowed after period of neutralization. Save settings by this button. Also, you can save sensor configuration in file and upload to next sensor. Let's update the sensor firmware. Start the firmware loader. Choose actual COM port. Let's read data from sensor. Power off the sensor and then power on. We will read current firmware version and configuration version. Choose firmware file. Choose configuration file. Click Write. To start flashing, we have to disconnect sensor from power shortly. Waiting for firmware flashing. New firmware will start after power off.